Okay. I spend most of my time trying to understand how climate change will affect this region, the Pacific Northwest, and that's what I'm going to talk to you about today. I also spend a lot of time these days trying to understand better what we might do about those impacts, how different people who make decisions about natural resources, for example, might incorporate climate change information into their planning. Normally, when I give a talk like this, I actually spend a lot of time saying what might happen, how likely it will be, who it might affect, how much change by when, where, how, that sort of thing. And so far, what we found is that at a regional level, at a national level, at the level of the planet, there hasn't been that much progress. So I'm going to start by doing something a little different than what I normally do, and I'm going to ask you a question specifically. And it looks like this. What does climate change mean for you? That makes it personal in some ways, right? What do the impacts of climate change mean for things that you care about, for things that matter to you? When we think about climate change and its impacts at the level of the planet, at the level of a region, a continent, it's hard to make it really interesting in the sense of something that you know about, that you think about, that you care about. Natural resource managers are in a position where it's their job, right, to understand the impacts to something that they manage. And so for them, it makes some more sense. But when we start to understand the impacts of climate change, what we might do to adapt to those impacts, it really has to be the answer to this question. What does it mean for me? What am I going to do about it? Now, Jim Hansen asked you this question, or something like it. What does it mean for generations that come after you? And in the sense, the decisions that we make now, the actions that we take now, the adaptation approaches, the strategies that we develop now based on the information that climate science has for us, has a lot to do with the answer to this question, because we're talking about a very long time into the future. Barry Lopez is a writer who has talked to climate scientists a couple times about how they might communicate themselves better. And one of the tips that Barry Lopez has for climate scientists and scientists in general is that when you give a talk to an audience that you don't know very well, you confess your bias up front. You tell that audience, where are you coming from? I'm coming from here. These are subalpine larches near Oval Peak in the North Cascades in the Lake Chelan Sawtooth Wilderness in Washington. I spend my time here because part of what I do in my job is to try and understand what the climate has looked like in the past millennium, the past 1,000 years. A lot of these larches are 300, 400, 500 years old. Some of them are 600, some 700, a few 800, a few 900. There are some that are 1,000 years old. Imagine what kind of stories they have to tell us about climate, and how can we better understand the variability in climate that we've seen in the past. How does our recent experience, which is only a century, compare to these kinds of trees? So I spend a lot of my time up here trying to understand what snowpack, for instance, has looked like in the last millennium. Sometimes we're fortunate enough to find individuals like this. This is a 1,000-year-old larch in Montana. This is a cross-section of a piece of wood. I didn't cut it out of this tree, just so you know, right? It's not the 1,000-year-old larch. It was buried in the rocks here, and it actually turns out that it dates back even before these old individuals that are out there in these rock piles. In fact, it goes back to 831 AD. This gives us a really long time frame in which to think about the way that climate has changed in the past, and how what we're seeing now differs from that past. Imagine standing there, we don't communicate with trees so much. The tree communicates more to us, right, through its rings. It tells us this story of the past. But imagine saying, the last 100 years, wow, these are really different than the 900 that went before them. And we know why at this point, right? We have a pretty good handle on what the physical processes, the changes in the planet, our behaviors, and how that all relates in terms of climate change. So what is changing up there? What's different up there? What can you see that is different? Well, it actually looks like this. If you're spending time in this system, which I have quite a bit, and you're not used to observing this landscape, it might not look any different. There's a bunch of larches there. Okay, so what? It turns out there are a whole lot of these little trees, right? These are all trees that are less than 100 years old for the most part. Everybody down here is many hundreds of years old. So for a long time, there were no trees establishing high in these alpine meadows. Recently, there are quite a number of them. Other people use images of glaciers to make the same point, right? There are changes that are happening very, very quickly in these landscapes. Okay, what does this have to do with climate change? This is looking back. This is sort of a retrospective. I asked you the question, what does it mean for you? So I'm going to talk a little bit now about Pacific Northwest climate change. We have this idea, right, that things are changing on the landscape before our very eyes. But is it because of climate change, or is that just natural variability? One take on this is to look at the data. What is the temperature trend in the Pacific Northwest over the last century? And that's what I'm showing you here. Data that goes back to about 1895. This is from the National Climatic Data Center. This is temperature averaged over the Pacific Northwest, so Washington, Oregon, Idaho, western Montana. The first thing that should jump out at you is actually that there's a lot of variability, right? From one year to the next, big increases, big decreases sometimes. That's the nature of climate. Climate from year to year to year to year, or even decade to decade sometimes, changes relatively rapidly. This year is different from last year, although this spring may not be all that different from last spring here. We all hope that it is, right? But year to year, there are significant changes. There are a couple other things, though, that I've drawn your eye to here. There are trends. That's what these lines indicate. There's a blue line there that shows the trend from 1920 on towards the more recent time period. There's a trend in green from the middle of the century on towards the recent past. There's a trend in orange, even more recent, right? Notice that the slope or the pitch of those lines changes as we move forward. That indicates that things are changing a little bit more quickly over those time periods. In the Pacific Northwest, no matter how you slice this data, it's kind of unavoidable that two things have happened. One is that there's been an increase in temperature of about 1.5 degrees Fahrenheit since the early part of the century, and 1 degree since mid-century, even though there's all that variability. Now, in the last few years, some have called attention to this, right, which is the decline in temperature that seems to be occurring in annual temperature over the last 7 years. Well, it turns out that kind of variability that we see, that's happened before here or here. It didn't mean that there wasn't a trend happening in the background all the time, right? Those time frames of change are too short to really be considered climate change. But when you start talking about 30 years, 40 years, 50 years, a century, that's the kind of time frame that we're talking about. Okay, so that's the recent past. That's what's been going on while these larches have been moving uphill. What else is going on, and what might we expect in the future? Climate, according to climate models, no matter how you slice it, and you heard this from Jim Hansen, will almost certainly keep warming. It's expected that temperature changes are going to be large relative to the variability that we have experienced in the recent past that I just showed you, on the order of several degrees. By the 2020s, averaged over the Pacific Northwest, you see a range of changes in these yellow and red bands, but we're expecting something like 2 degrees Fahrenheit, averaged over the 30 years or so centered on the 2020s. By the 2040s, that would be 3 or even more degrees Fahrenheit, and by the 2080s, 5 or even more degrees Fahrenheit. Now you notice that that range of changes gets wider as you move into the future. That's because we don't know in the future exactly what fossil fuel emissions will look like. The choices that we make today have very much to do with how the latter part of the century unfolds. The increase in temperature that we would get even under a moderate emissions scenario by the end of the 2080s or the end of the 21st century would be several degrees Fahrenheit warmer than it is over the latter part of the 20th century, which is what's in gray here. What you're looking at is this range of many different climate models, roughly 20 of them in these bands. And so that gives you the range of different modeling choices that different modeling groups make. It gives you some feel for the range of changes we might expect, but all of them show an increase. Now, what about precipitation? Precipitation is a different story. The range of precipitation year to year, decade to decade in the Pacific Northwest is so large that the expected changes we would get, given the climate forcings anticipated for the 21st century, are relatively small, 4 or 5% change in annual precipitation. Doesn't sound like very much, but it's worth noting that in the Pacific Northwest, the consequences of that change in precipitation depend on what the seasonal change actually looks like. And what the climate models suggest is that there's an intensification or an increase in the ordinary discrepancy that we have between our dry summers and our very wet winters. You get an increase in the wet winters and a decrease in precipitation in our already dry summers. So that change from wintertime to summertime is a big deal in terms of the impacts that we might expect in the future. Okay, what are some of those impacts? The first big one, and the one that really characterizes the Pacific Northwest, is the changes in snowpack. I picked 3 iconic examples that I'm going to share with you today. The first one is snowpack. We live in a region where we set global records for the amount of measured snowpack that accumulates in a season, right? Mount Baker had the record several years ago. Why does snowpack change? We have an increase in wintertime precipitation. Why would we lose snowpack? Well, there's two reasons. One is that in our region, most of the precipitation that falls in the wintertime falls near freezing. It's not like the Colorado Rockies or Alberta, where most of the precipitation falls as snow and it falls during very cold storms. Here, it falls pretty close to freezing. So a couple degrees of change actually pushes it past that transition from snow to rain. So you get an increase in rain. Rain runs off. It doesn't accumulate like snowpack, and so you get a smaller snowpack. The second thing is that as it warms, springtime comes earlier, right? The melt of snowpack comes earlier. And so those two effects work together to decrease snowpack. We would expect roughly 35 to 45% decline in snowpack averaged over Washington State by the 2040s, the middle of this century. When you start to look at an increase of 4 degrees Fahrenheit, much like we might expect for the latter part of the 21st century, and an increase in wintertime precipitation, you're still getting large declines in snowpack in most of the Pacific Northwest. That's what these red colors on the chart behind me show. The deeper the red, the more decrease you get. Only the places that are white or even blue are places where snowpack stays the same or even increases in a couple of high elevation places where it's still cold enough for most of that winter precip to become snow. So the increase in precipitation gives an increase in snowpack at the highest elevations. Okay, the second change, salmon, another iconic piece of the Pacific Northwest. When people say, what does it mean for me when I live here? Salmon are a big part of our identity in this region. Salmon are affected by climate change in a couple of different ways. One is that air temperature, as it increases, influences stream temperature directly. And as stream temperatures warm, it becomes less favorable for salmon once it's past a certain threshold. It turns out that threshold is pretty close to room temperature. And that's what this graph is showing you back here. What those yellows and reds on the map indicate places that are unfavorable for salmon because the temperature in late summer in those stream reaches is too high for them to successfully migrate and spawn. The blue places are places where it's favorable for salmon. And as you can see, by the 2040s in most of Washington, you get a pretty sizable decline in the area of favorable habitat for salmon. Another impact for them is the change in flooding regimes, right, which affects the available habitat for rearing eggs and young salmon. And when you get an increase in flood regimes, it has different effects for different species, different runs of salmon. Okay, a third iconic piece of the Pacific Northwest, forests. An increase in temperature does a number of things to forests, but the two most important are that it decreases the water availability to trees, and that increases both fire danger and the risk of insect outbreaks. It also makes the insects themselves more able to colonize higher elevations than they have in the past. So you expect more insect outbreaks in many kinds of our forests, particularly in pine forests. What you're looking at here is a chart of the increase in area burned in the Blue Mountains in Oregon. This is a very fire-prone area already. And you increase the temperature a couple of degrees and the area burned by fire goes up very, very quickly. And so you get a fundamental change in that ecosystem. So those are just 3 examples. I don't have time to go into all of them. We're too short here. 4, 5, 6, 7, 8, 9, right? Different sectors, coasts, agriculture, human health, energy, transportation. The point I'm trying to make to you is that this region has impacts in almost every sector that you can think about of climate change. Now, not all of them are fundamentally negative. Increases in potato yields, for example, are something we might expect, provided there's sufficient water to irrigate potatoes. Because the carbon dioxide effects and the increase in temperature are good for plants. So we get an increase in some agricultural yields. But in many cases, the impacts are not so rosy. Not all of the effects of climate change are bad news, right? But a lot of them are expensive game changers, and many of them represent a fundamental change in what it means to live in this place. So when I ask you that question, what does climate change mean for you? It means a change in the nature of the Pacific Northwest, the things that we use to identify our region, the way we identify ourselves to some degree. The good news is that someone's listening. Planning and action to decrease emissions and increase resilience are underway. So this report was released by the Washington Department of Ecology this month. This is actually an integrated strategy for how to deal with climate change in our state. Federal agencies, state and local governments are beginning to lead the way in spite of a lack of organized federal leadership. That's exciting. That's good news. Someone is listening and doing something. So who should do what to change what is? That's the question, right? Who is going to do something differently because of this information on climate change impacts in the Pacific Northwest? Well, I hope we all will. And with that, I'll close with this. I think because we comprehend the problem, right, we have a responsibility. We can imagine and act on the solutions, all of us, right? All of us. It's not just something that happens in a federal or planetary level, it's local as well. So with that, I'll close. Thank you.